Hi everyone, I'm Andrew Guyman. I'm a fourth year medical student at the University of South Dakota. We're continuing our Anesthesiology 101 lecture today on day 12, discussing opioid and local anesthetic calculations. So the first problem that we have is a patient is under your care in the perioperative service and has been receiving 1 milligram of Dilaudid IV, otherwise known as hydromorphone, every 4 hours after their operation. In preparation for the patient to go home, you want to transition to oral hydromorphone. What will you order? So the first step that's very important to me is you always write out your givens when you're solving any problem like this. So we have a patient who has been receiving 1 milligram of hydromorphone IV and every 4 hours. And they want to transition to oral hydromorphone. So what we're trying to calculate is hydromorphone PO question mark. And to do this, we need to have the conversion between oral hydromorphone and IV hydromorphone. And that's going to be 1.5 milligrams hydromorphone IV equals 7.5 milligrams hydromorphone PO. Okay, so now we should have enough to be able to solve the problem. The first step that we need to do is calculate our 24-hour dose. So they've been receiving 1 milligram hydromorphone IV. Units are so important. Every 4 hours. So 4 hours. And then we're converting to every 24 hours. So put 4 hours on top. That's our units. We're converting to 24 hours. So 6 4-hour units equals 1 24-hour unit. Our units cancel out. And now we're left with 6 milligrams hydromorphone IV every 24 hours. Now we need to convert from IV hydromorphone to PO hydromorphone, and we have our conversion right here. So we have 1.5 milligrams hydromorphone IV. Hydromorphone IV is equivalent to 7.5 milligrams hydromorphone PO. And we'll bring that down here. So if we run that really quick, get 6 times 7.5 is 45, divided by 1.5 is 30. So 30 milligrams hydromorphone PO per 24 hours. And then after we've calculated our total dose and converted our medication, now we need to calculate the new frequency. So we're not going to just give them 30 milligrams once a day, but our conversion is every 4 hours. So instead of once every 24 hours, we're going to go 6 times every 4 hours. I'm just checking that this makes sense. So 1 24-hour unit is the same as 6 4-hour units. So we can cancel these out. And then we're left with 30 divided by 6, which is going to be 5 milligrams hydromorphone PO by mouth every 4 hours. And then we'll box in our final answer, and hopefully that makes sense. For our next problem, we have a patient taking sustained release oxycodone, 100 milligrams every 12 hours, but they have developed sedation, and they want to switch to hydromorphone every 6 hours. First, what is the equivalent dose, accounting the equivalent dose of hydromorphone, and then accounting for 50% cross tolerance. So just like on our previous problem, if you're trying to solve these, the first step is make sure that you write down your givens. So we have 100 milligrams of oxycodone and every 12 hours, and they want to switch to hydromorphone every 6 hours. So we'll say this is the initial timing, this is our initial medication, and then we want to switch to hydromorphone 6 hours. So final timing, and then we want to know the hydromorphone PO dosing. That's our question. And we would also definitely then need the conversion factor between oxycodone and hydromorphone PO. We have that. We look at our chart and we see that oxycodone, so we'll say 20 milligrams oxy equals 7.5 milligrams hydromorphone. Okay, so now we should have enough to be able to solve our problem. We're going to start with first, right here, step 1, calculating our 24-hour dose. So 100 milligrams oxy, and then that's going to be per every 12 hours. First, let's calculate to, or convert to, from 12 hours to 24 hours. This is how much they're taking in one day. So 2 12-hour units is equal to 1 24-hour unit. So now we have how much oxy is being taken every 12 hours, and now we need to convert from oxycodone to hydromorphone. And our conversion from milligrams oxy to milligrams hydromorphone is going to be 20 milligrams oxy equals 7.5 milligrams hydromorphone. So this is step 2 that we just completed there. And then we're going to calculate our new frequency. So now we have milligrams of oxycodone per 24 hours, and we're converting from 24-hour units back down to every 6 hours. So one 24-hour unit is equivalent to 4 6-hour units. And then that should leave us with, cancel out our units here, milligrams. Let's see. So these units are canceled out here and here. So now we're at milligrams hydromorphone per 6-hour units. and we're accounting for 50%, so times 0.5 or 50, we'll say, times 50% cross tolerance. And now we can go ahead and calculate our answer. So to do this, we'll take 100 milligrams times 2 here times 7.5 equals, and then divide by 20, and then divide by 4, and then take that times 0.5 equals 9.35 milligrams oxycodone per 6 hours. Box in our answer. In reality, we would probably round this up to 10. Now, I just wanted to add one last caveat here. So what we calculated is about 9.4 milligrams of oxy every 6 hours, and that's according to the question stem in our workbook that gave a calculation of hydromorphone every 6 hours. Our workbook gives a different answer, approximately 6.5 milligrams, but you'll notice that this is 6.5 milligrams of hydromorphone every 4 hours. So that's according to hydromorphone in the table having or providing analgesia for 4 hours. Both of these numbers are reasonable. The reason that they have 6.5 milligrams every 4 hours is if you were to switch this portion of our calculation here and calculate every 4 hours, so then it would be 6 units every 4 hours. Then as we multiplied this through, we would divide by 6 rather than 4, and then that would give us this answer. Both are reasonable, it just would depend on how frequently you would want to dose your medication. So we have our last opioid calculation problem here. Patient has used 45 milligrams IV hydromorphone over the previous 24 hours on her IV hydromorphone PCA. What 24-hour dose of oxycodone would she need to receive the next day to receive an equipotent dose of opioids with 50% cross tolerance? So our first step, as always, is going to be write down our givens so we don't get our wires crossed. The first number that we're given up here is 45 milligrams IV, we'll say 45 milligrams hydromorphone IV. Next number that we're given is over the previous 24 hours, so we'll say Q 24 hours on her IV hydromorphone PCA. What 24-hour dose of oxycodone would she need to receive? So our timing for our final value is going to be 24 hours because we're determining what 24-hour dose of oxycodone would she need to receive to have an equipotent dose. So we're looking for oxy dose. Now we know what we're trying to find. And then 50% cross tolerance. So we don't forget about that. Cross tolerance. And then we need to know our conversion from hydromorphone to oxycodone. That's going to be, we just did this in our last problem, but 20 milligrams oxy equals 1.5 milligrams hydromorphone IV. So it's more potent because it's being given IV. Regardless, this is our conversion factor. So we can start off with where our patient was at. So they received 45 milligrams of hydromorphone IV every 24 hours. So we already have what we did, step 0, which is writing our givens. Step 1 was given to us, calculating a 24-hour dose. They told us that. Now we're converting our medication. So we're converting from hydromorphone IV to oxycodone. Conversion is 20 milligrams of oxycodone is equivalent to 1.5 milligrams of hydromorphone IV. So these cancel out. Now we would be, we have our total amount of oxycodone every 24 hours. And that's exactly what this question was asking for. So we already have the frequency as well. Now we just need to account for the 50% cross tolerance. So times 50%, we need to reduce our dose by 50% to make sure they're not overly sedated or affected by the side effects, and we can calculate our answer. So what we have is 45 times 20 divided by 1.5 times 0.5 equals 300 milligrams of oxycodone every 24 hours. Hope that makes sense. So our final problem is a local anesthetic calculation problem. So we have a 70 kilogram patient receives 10 cc's of 2% lidocaine with epinephrine. Epinephrine is at a dose of 1 per 200,000. Locally, when an ER doc sutures up a laceration on their left forearm, an anesthesiologist then comes and performs a supraclavicular nerve block, we'll say on their right arm, using 20 milliliters of 0.25% bupivacaine. How many milligrams of lidocaine, epinephrine, and bupivacaine did the patient receive? So first, again, we'll write down our givens. So our patient weight equals 70 kilograms. Lidocaine dose equals 10 cc's at 2%. Bupivacaine dose equals 20 cc's at 0.25%. And then our epi dose equals 10 cc's at a dose of 1 per 200,000. So for local anesthetics, the trick, I'm sure that you've heard this at some point, is move the decimal place one place to the right, and then that's going to give you the number of milligrams per cc. So for lidocaine, 2% goes to 20 milligrams per cc, and then we said 10 cc's, so times 10 cc's equals 200 milligrams lido. And then for bupivacaine, We'll change colors here so we don't get confused. Bupivacaine is 0.25%, goes to 2.5 milligrams per cc, and we said that they used 20 milliliters or 20 cc's, so times 20 equals, that'll be 50 milligrams bupivacaine. And then the trick for calculating epi is using it's called the rule of a million. So you would take, again, we'll change colors, but you would take 1 million divided by 200,000, this number here, equals 5. And then that gives you mics of epi per cc. So the epi was 10 cc's of Lida with epi was used. So that's going to be 50 mics epi. And then part B asks if any of these values exceed the maximal toxic dose. So the maximal toxic dose is calculated using the rule of 3, 5, 7. This was a question that Dr. Toom pimped me on, so it's a good rule to know. But the maximal dose of bupivacaine and ropivacaine is 3 milliliters per kilogram. So if we have a 70 kilogram patient and the maximal dose is 3 milligrams per kilogram, we wouldn't want to exceed 3 times 70, which is going to be 210 milligrams bupivacaine. And we can see that we didn't. We were at 50 milligrams bupivacaine. And then for lidocaine, so lidocaine without epi has a maximal toxic dose of 5 milligrams per kilogram right here. Now, that's less than lidocaine with epi, which is 7 milligrams per kilogram, because once you have epi in there, that causes vasoconstriction and makes it less likely for the local anesthetic to diffuse systemically throughout the body and cause systemic toxicity. For our case, we had lidocaine with epi, so we're going to use this number of a maximal toxic dose of 7 milligrams per kilogram. So again, we have our 70 kilogram patient. The maximal toxic dose is 7 milligrams per kilogram. Cancel out our units here. That equals 7 times 70, which is going to be 490 milligrams lidocaine. And we used 200 milligrams lidocaine, so less than the maximal toxic dose. Now, in reality, you probably get some crossover between the lidocaine and bupivacaine, so you would need to have some sort of calculation to kind of like merge these values together, and then also merge like your maximal toxic dose would be somewhere between 210 and 490. For this example, we just calculated them separately to demonstrate the concept. I hope that helps. Let me know if you have any questions.